All right, everybody, welcome into for today. We have a special guest. His name is Professor Nixy. You guys may know him from TikTok, and we're gonna have a great discussion about astronomy and stuff like that. So let's welcome in Professor Nixy. How are you?
I'm doing well. How are you doing? It's a pleasure to have you. Or you have me. Thank you very kindly.
Yeah, no problem. I know you're busy and everything, but so thanks for being here for that. Now, tell us a little bit more about yourself and then your background. I know you do astronomy, but and you're an astronomer, but tell us more about your background.
So I went to college. I got my degrees in math and physics. I did not get a degree in astronomy. I am a software developer, and on the side, I did astronomy. I actually helped develop things like OpenSSL back in the late 90s. So I'm a pretty accomplished software developer. My side hobby was astronomy, and I started testing robotic telescope mounts with a company called Software Bisque, and I started finding asteroids. And I
Mm,
wanted to know more than that they were asteroids, and I started submitting the data to the Minor Planet Center, and I ended up discovering multiple asteroids and helping with the refinement of the orbits of other asteroids. And I did a total of about 80,000 observations using robotic telescopes. And as I was doing that, I'm fascinated by galaxies.
mm,
And I started finding supernovas going off in galaxies and we're reporting those. So down the line, I wrote scientific papers talking about supernovas and minor planets. Meantime, I'm also a software developer during the day. And
mm.
about 2.5 years ago, 2 years ago, I'm on TikTok and I'm in a live just talking about software development, actually. And somebody said, "Hey, I've never seen the moon through a telescope." So I pulled out my telescope, set up my cell phone, and the next thing you know, there's 20,000 people in the room asking me questions about the moon. I've taught astronomy at a college level. I've taught quantum mechanics. So I'm a citizen scientist, and that's who I am.
Wow, that's a hefty background there. It's interesting that you able to actually see all those supernovae. That's very interesting. Um, yeah, I love seeing your lives on TikTok. Through your telescopes. I love seeing it, looking at the sun, looking at the moon, even. Um, but yeah, so the first thing I want to get to is galaxy formation. I know a couple months back there was this big controversy about the Big Bang and the James Webb findings. What exactly did they find, and does this put any dent in the Big Bang theory or model?
Okay, so what was in a scientific paper? So I want to start that this is not a scientific article. The actual paper suggested that these galaxies were very well formed. They were about 800, they were about 400 million years after the Big Bang.
Mm,
They do not put the Big Bang in jeopardy. The Big Bang does not describe how galaxies formed, it talks about the expansion of the universe.
mm,
So they could be newly formed 250 million years after the Big Bang or a billion years. That has no merit in the Big Bang. The Big Bang is all about the expansion of the universe. It's not even about the birth of the universe, it's about the expansion.
right.
So anybody who's claiming that it has anything to do with the Big Bang doesn't understand the Big Bang. Now, galaxy formation models are about how did the earliest galaxies form? And the thing about that is we have no evidence. Hubble can see things about 800 million years after the Big Bang. And we have an embryo picture of the universe called the
Mm,
cosmic microwave background radiation. And we have absolutely nothing in between. So it would be equivalent to me going to a biologist saying, "This is a human embryo. Here's an 18-year-old. Tell me how they developed."
right, right.
So how many models could you come up with of how was it linear? Was it like this? Was it like
Mm,
this? How did they get there? and we built the JWST, or the James Webb Infrared Telescope, to give us data so we could take our predictions and say, hmm, which one of these fit? And if you would have asked 9 out of 10 astronomers or astrophysicists, they would have said, the universe is going to surprise us because it always
Mm.
does. Now, that particular paper, those galaxies are older than initial calculations. So they fit the existing model. But we're keep finding well-formed galaxies very early. And that's making us think that galaxy formation happened much more rapid than most of the models. But all the models are hypothesis because we had no data. So
Mm.
now we're able to look at the model of the universe and go, okay, what really happened? So you're in a revolution right now with JWST being able to see the early universe.
Yeah, that is quite remarkable. I think the James Webb goes back to a couple 100 million years after the Big Bang.
Yeah, I think the earliest one, and I might get the number wrong, is about 250 to
Mm.
275 million years after the Big Bang.
Yeah, that's quite incredible. So, do we have any other knowledge about the galaxy formation? I know that galactic filaments are something we're just now finding more about. Do galactic filaments have to do with it? Like, I know they spin, there's a cosmic web of all these filaments throughout the universe. Does that have anything to do with perhaps galaxy formation? You know?
No, that is the um, how, let me think of the best way to word this. So galaxy clusters form lines,
Mm,
and they correspond to the warm regions in the cosmic microwave background radiation. And in between them, we have great voids. Now, that's much larger scale than a galaxy. So we have these structures, or the web, and that was really discovered by the Sloan Digital Sky Survey, when we could get distances to all these galaxy clusters so we
mm,
could build a three-dimensional model. And that web, we're going to really get more information in 2027. We're launching the Roman spacecraft, which is going to give us a
mm.
wide field view to look for dark matter and to flush out that web that was started by the Sloan Digital Sky Survey.
Wow, that's going to be a game changer for sure. That's going to be crazy. Speaking of dark matter, there is this idea of primordial black holes being or taking the place of dark matter. Do you know anything about that? Do you have any ideas about that?
So there are a lot of hypotheses on what dark matter can be.
Mm,
And the leading hypothesis are primordial black holes, which would be quantum in size, extremely
mm,
small, stable objects. The other candidates are axions, and the other candidate is WIMPs. They're both different subatomic particles, and neither are predicted by the standard model of physics, which it gives us electrons and leptons and quarks and those things. Well, JWST has discovered dark stars. These are massive objects that are radiating very cold, very cool, but they're extremely large. So they're too big to be a star. These things are the size of galactic cores, but they're not hot enough to be another theory, which were black hole stars, where a black hole will immediately form from the hydrogen gas that was dense in the early universe, and then they would heat the gas around them, and we would see these hot, big stars called um, uh, black hole stars.
mm,
But James Webb has found four candidate dark stars, and that leads us to WIMPs. WIMPs would cause these types of objects. So I think JWST is beginning to give us candidates for
mm,
the particle physicists to go figure out. Here's the beauty of astronomy. we have to work with geologists and we have to work
Mm,
with particle physicists. We don't have all the answers, cosmologists. It's getting everyone together. Like astronomers thought all the water came from comets, and the geologists figured out it came from the Earth's crust.
mm.
So you have to listen to all this science to figure it out. So if I was going to hedge a bet a year ago, it would have been black hole stars and primordial, black holes. No, it really looks like WIMPs.
Wow, that's really exciting because I mean we're living the times of this James Webb and these gigantic telescopes, which can give us tremendous insights on the Big Bang, and we've never really had this many insights before since probably Einstein. So this is a great time to be alive and be an astronomer. Um, Awesome, that's great. And the next quick question is about solar flares. I know I heard a couple months ago they're peeking into a new cycle. Is there going to be a major flare? Do we have any concerns? Is there anything major going to happen in the
Okay,
world?
so you're hitting my live channel, 5 days a
Yeah.
week or so, I show the sun. Solar flares are not dangerous to the Earth.
Mm,
People confuse solar flares and coronal mass eruptions.
mm,
A solar flare can cause a coronal mass eruption. So let's just this a solar flare is when you get magnetic fields and they rub up against each other like your hands, and
mm,
they heat material to over 10 million, 50 million degrees, and they shower the solar system with X-rays. Those X-rays hit the Earth, and the Earth has this thing called the ionosphere. It heats up, and if the flare is big enough, it'll prevent radio waves being sent by mankind from bouncing back down. So pilots and ships have a harder time communicating when we have large flares. That's about all flares do.
mm,
Now, can happen is the flare can break and snap. And this hot plasma, this hydrogen plasma, can get showered into the solar system. Those large pockets of millions of metric tons of plasma are magnetically charged. Those CMEs can hit the Earth, and depending on the polarity of the burst and the Earth's polarity, they can get through. They're what cause the aurora borealis, are these charged particles. In the 1800s, there was an event called the Kerrigan event,
mm.
and it melted telegraph wires. But don't be
Wow.
afraid, because that event was the largest we've ever seen, but we didn't ground things the way we do today with surge protectors. So we've
Mm.
had some outages in the 1970s and 80s with coronal mass eruptions, but they're very localized because they can cause power spikes in wires. The other thing is the sun is on an 11-year cycle, and
Mhm.
we can't predict a solar storm, but we can say we're entering that solar maximum when the sun gets very active, and we're just entering that for the next few years.
Wow, that's incredible. Um, so there's no I mean, is it possible that the solar or this coronal mass ejection can disrupt our radio now today or cause blackouts today?
It can get through and cause localized blackouts. It can take out satellites. Yes,
Okay.
it's
But
extremely rare.
yeah, yeah, right. But like the worst case scenario, like is it possible that there's a global blackout?
Yes, there could be,
Wow.
but that would
Okay.
be more massive than anything
Yeah. Right.
but there is no evidence that the sun has ever caused a mass extinction or an
Mm,
extinction event. It
right.
can disrupt our technology, which would be it could be very problematic, but it's not going to harm humans
Physically.
or animals.
Right.
It'll
Okay.
affect our technology.
Well, technology is everything now, so,
True.
um alright, great. Thanks for that. And then, we're gonna get into life. I'm gonna talk about, like, a little bit about astrobiology. Um, a good place to start is Mars. Um, We now know that we look out in the universe and we see biosignatures, and those are basically chemicals that you know seem to pertain to some living organism instead of some kind of geological thing happening. So Mars is Mars a good candidate for life? Is there life on it now? Did it have life on the in its past? Is it possible?
Okay, so does it have life today? Undetermined. If it does, it's probably subterranean. We
Mm,
know that Mars once flowed water, and with endurance and spirit and opportunity, we found that the water that was on Mars was not toxic. It was very similar to conditions to what we have. We know that water flowed. We've seen all the things. Where there's flowing water on Earth, we find evidence of life. But that was 3 billion years ago.
mm,
So the evidence of fossils or microbial life is long gone. It has degraded.
mm.
So could Mars have had life in the past? Yes, but we don't have the tangible evidence yet. But my gut would tell me yes, but my gut doesn't count.
Exactly. That's how science works. Um, so Mars today has a very small atmosphere. Probably it's not very protective if there's life on the surface. So, like you said, it'd be subterranean, under perhaps inside of ice. And I heard that there's actually liquid water under the surface. I think there's some evidence of liquid water present. Is that
Yes.
is correct? Okay.
Yeah, we've seen craters and there will be a collapse and water will flow out of it and evaporate.
Mm,
And we've seen that through the satellites. So we know there's liquid water underneath, but we haven't been able, it hasn't happened where we have any of our robots. I mean, think about it. We got 5 robots that cover a surface area of a couple square meters, and these events happen willy nilly. But so we know there's liquid water. Could there be subterranean life? Maybe.
yeah. I mean, I believe there's more water on Mars than Earth. Well, there was at one point, but there's a lot of water on Mars.
There
Um,
was a lot of water on Mars.
yeah.
Not as much as the
The
Earth.
Yeah. Okay. Um, but the problem with Mars is that it had the right conditions, but not for a very long time. It probably was. There's a probably small window where life was very possible on Mars.
About a billion years.
About a billion, yeah. And that's
So
it's not enough really to have more intelligent life like us. It's most likely bacterial.
right. And we would be happy with finding one back
Oh, yeah.
microbe. I mean, that would be game
Oh, yeah.
changer. Um, and realize on the Earth it took 3 billion years, 3.5 billion years of microbial life to change the environment before animals existed.
Mm,
Multi-celled life, the Cambrian explosion, when oxygen became prevalent in the atmosphere.
all right. Um, okay, that's interesting. Gravity is another thing as well. Mars has lower gravity, so water and atmosphere would be stripped away more easily. So let's segue over to Enceladus, which is one of my favorite objects in the solar system by far. It's like a winter wonderland, I call it. Um, and I think that life is on Enceladus. I think that's a very good candidate. What do you think?
I
Is there life now on it now? Is it possible that life exists on Enceladus? What do you think?
So Enceladus is a moon of Saturn, and this is for the audience that may not know what it is. It's
Mm,
responsible for the F ring around Saturn.
mm,
It has geysers shooting out, and we were able to sample those geysers with the Cassini spacecraft. And
mm,
it was not designed to physically touch the water, so we had to use light to sample it, and it discovered a bunch of chemicals that are, and it's a saltwater ocean, that are very, very common in life, including a phosphate. So we are seeing the calling card of life, but we haven't seen life. And we haven't seen anything to the point that we can go, yeah, that has to be life. But it's like, oh, that smells like life. So I think it's the best candidate because the geysers are telling us what the oceans are. And
Mm.
the European Space Agency just sent a probe out there that has much better equipment, and so is NASA, so we can really start finding out what's going on in there because it's a saltwater ocean with phosphates.
Yeah, that's a really remarkable thing. Um, for those of you guys who are listening who don't know, Enceladus has a very like a 30-mile thick layer of ice on its surface. But under that ice is a entire ocean, a saltwater ocean, very similar to the saltwater oceans on Earth. And we have found like with Cassini many amino acids. Um, but now we're finding more and more ingredients. In fact, now we know that Enceladus has every single ingredient required for life as we know it. Water, energy, tidal stress, right? All these things can provide energy and the right ingredients for life. So I think it's the best candidate by far in our solar system. Um, Next, exoplanets. Um, we've discovered about 5,000 planets outside of our star system, which is some of them light years, hundreds, thousand light years away. Um, what do you think about the types of life we can find out there on those planets? Um, would they have similar biochemistry? Because we know that there's many different alternatives to DNA nucleobases. There could be all kinds of LNA, RNAs, XNAs. So, what do you think we'll find out there? And tell us about the planet we discovered sulfides on.
So we don't know how to detect what we don't know. So all those examples where we don't know how it operates, we may discover something like that because it's just ultra weird when we get to detect enough worlds. So we're really focusing on, carbon, water, nitrogen are really, really common in the universe. What we're made out of are some of the most abundant materials. So
Mm,
let's focus on what we know. And one of the chemical compounds that we know here on Earth that is only abundant because life produces it are sulfides. Sulfides are created, generally speaking, through bacteria. And this is, basic bacteria produce sulfides. And these sulfides have been detected on K2-18b. Now, we're going to double check to make sure that we didn't get it wrong. We have one sampling of their atmosphere. The next time the planet comes around, we're going to take the light onto the JWST telescope and look at the spectrograph and make sure we have sulfides. Those sulfides, if they're in a high enough concentration, the only way we know from chemistry, remember we talked about you have to bring in somebody other than an astronomer. Chemists and biochemists only know of ways to get small amounts of sulfides that we wouldn't be able to detect with the JWST through other processes. So that's one way we're going to detect bacterial life. Now, how would we detect a modern society? That would be artificial elements like fluorides, carbon fluorides in the atmosphere. So if you were an alien culture and you took a picture of the Earth today, obviously you have to be pretty close to see it, you would see all these chemical compounds you do not find in nature. You only find them because humans have synthesized these chemicals. That's how we would detect a society. We wouldn't be able to tell their RNA or their DNA, but we would be able to detect these artificially put together compounds in large quantities.
right, and they would have to be sustained so that there's a current presence of them there. That's really interesting. But before we go into intelligent life more in depth, I want to go into the types of exoplanets we found. Can you tell us a little bit more about how exactly we find these planets? Because they're really far away and they're super, super dark. And so, how exactly do we find these planets? And then how do we detect what's in their atmospheres?
So the way most planets are detected are through transients. There's really two methods for finding planets. You have a star and you have a planet. And when the planet goes around like this, the star is pulled by the planet, no matter its size. Even Pluto will tug on the it's a mutual gravity.
Mm,
So the larger the planet, the more it tugs. And as it tugs the star will wobble. And we've been able to detect planets by wobbling. And if we see the wobble and it's predictable, we can determine that there's a planet or multiple planets causing the wobble. That doesn't let us sample the atmospheres of the planets. We can say there's 3 planets, one is as far away as Jupiter, and it's 3 times the mass of Jupiter. Or the easiest ones to detect is a really big planet right next to the
mm,
star because it causes a lot of wobble. So
mm,
those were the first planets we detected because 'cause they're the easiest.
mm,
Now, at that point in time, at no point in time do we have a telescope that we can see the planet. It's a million times or more dimmer than the star, and you have the glare of the star. We can't see it. But every once in a while, because there's only 360 degrees in a circle, the planet goes around like this. We can still see the wobble, but the wobble is only in one dimension. And sometimes that planet's in alignment with the Earth and us, and the planet goes in front of the star. And when it goes
mm,
in front of the star, some of the light shines through the atmosphere if the
mm,
planet has an atmosphere. Light tells us what's absorbed and what's given back, and that tells us what chemical compounds, it's called spectroscopy. This
mm,
is if you've ever watched CSI and they put something in a machine and they go, "Oh, that's gotta be chocolate," or "That's a blue gene," or "That's whatever." They do spectroscopy. They heat it up, and the light tells the machine what it's made out of. It's like DNA, but for elements and molecules.
mm.
So that atmosphere, the light through it is telling us what that atmosphere is made out of. And that's how we can determine whether it has sulfides, oxygen, nitrogen, what it's made out of. The light tells us everything.
Yeah, that's utterly genius how we discovered that, how we figured these things out. That's why I love science. Um, yeah, so I want to pick on something you said before. You said that we find mostly, well, the first things we found were these hot, big Jupiters right close to their stars. Um, is it maybe we're just presupposing that these are the most common, but what do you think is the most common type of star system? What do you think is the most common type of planet? Because do you think it's the hot Jupiters, or do you think there's other types of planets, or do you think there's just a mix of them?
I would say we don't have a large enough statistical sample to hedge a bet at this point in time.
Okay.
We're just learning how to detect them.
Mhm,
And a lot of times it takes 10 years of studying a star to determine the orbits of everything. And we'll get better at it and we'll get more and more information. And we launched the Kepler mission, which gave us most of these candidates looking for transits. And it only operated for 5 or 6 years because it was a test. Would
mm,
this work? It did. Now we can build better instruments to do better science. So
right.
to say, "Oh, this is what it is," or we have 5,000 planets and there's
Yeah.
200 million stars. We're not at a point where statistically we can say. So I will say to my students that the reason we found hot Jupiters is they're the easiest to find,
Right.
and they were the first we found because, well, they're the easiest. as
Right.
our techniques get better, give us 30, 50 years, we'll be able to answer your question. I want to answer it.
Right. But I think that um, the fact that when we took a look at the galaxy, we know that there's about 80% of the stars are about they're M type stars, which are much smaller than our sun, the red dwarfs. What would that give us any insight on the types of planets around them? Is it perhaps that these are smaller or less dense planetary disks, such that when these planets form, there's less stuff to accumulate, turn into rocky material? Is that a possibility? Um,
We've seen rocky worlds around red dwarfs.
mm,
Personally, I don't like looking around red dwarfs particularly because red dwarf stars are very violent.
mm,
See, our star is big enough that when we have these explosions, most of the material falls back. You have to have a much
mm,
higher explosion to get out. So these red dwarf stars are more common and they may contain life, but they can also wipe out life far easier
right,
because their magnetic storms reach their worlds because those worlds have to be much closer to the star.
right.
So I really like looking in the bigger stars closer to the sun. And yet again, it's what we understand better. It doesn't
Exactly.
mean don't look there, but we have 50 billion stars that we can look at that are similar to the sun.
Right.
That's a good sample.
Right. Um, Now, when it comes to Jupiters, we know that those are the easiest ones to find. But now we're with the James Webb, we're able to actually discover these atmospheres. And the thing is, we're finding a lot of worlds that are mostly made of water. And what that allows us to do is we can now more be more keen on these specific planets that have oceans, that are ocean worlds, because they have atmospheres. So do you think that life is more common in these ocean worlds? Do you think that life can persist in these ocean worlds, near any type of star? Such that it doesn't matter what star we look at, if there's an ocean world, there's life there, most likely?
These ocean worlds are what we call they're bigger than the Earth. So let's go
Mm,
back. These are
okay,
super Earths. They're
right.
4 times the mass of the Earth, and we're finding them very common at this point. Yet again, it's easier to find big things. So I don't
Mhm,
want to say these are going to be the most prevalent because
right.
I can't say that. But these super Earths all appear to have a large water ocean. They might be completely covered in water. Well, the good thing about being completely covered in water, the super Earths have strong magnetic fields because they're bigger than the Earth. They also protect the organisms from ultraviolet light.
Mm,
That's a blessing and a curse because ultraviolet light can also cause mutations. So it's a whole different ball game of what kind of life could exist. But if you find liquid water, I think it's going to be a good place to look for life. And I
right.
suspect those worlds, as we get them in front of the web, we're going to start seeing more sulfites and
Mm,
higher oxygen environments. Oxygen is probably the best indicator of life
interesting.
because the only way you can get a rich oxygen atmosphere is through photosynthesis.
Right.
Life is what produces oxygen. Oxygen does not want to be alone. It wants to
Mm,
make carbon dioxide. It wants to
right.
make other things. So you continually have to create oxygen. And the only way to really do that on a planetary scale is life.
Right. Yeah, so in terms of our type of life as we know it, um, we would need things like you said, oxygen, all these things, because you also need land as well. So although those ocean worlds might be hospitable for life, they might be bacterial, they might be microbial, or fish-like species, not really ending up intelligent as we, because perhaps we know how we evolved. Being on land helped us discover fire, which helped us. discover new energy sources. So perhaps perhaps planets like the Earth would that have land on them are more hospitable for more intelligent forms of life. Um, things like um, a magnetic field as well, protecting us from those UV rays and X rays. That's important as well. So, do you think that intelligent life is more common on rocky planets, or do you think intelligent life could exist anywhere?
I think that if you look at octopi and cuttlefish,
Mm,
they check off a lot of boxes of intelligent. Now,
mm,
it's difficult to build a computer underwater, but I'm not gonna rule it out. I don't know how they would do it, but you know what? Life finds a way.
right.
Um, so I think, you see Star Trek and everybody's a biped walking around. That's because
Mm,
it's really difficult. We may find intelligent life and it may be water based. It may live in water. It may have figured out a way to do it. There's a lot of drawbacks to that, but there's also a lot of good aspects to that. So to throw out the water worlds and go, nah, there's no intelligent life there. I don't
mm.
know. Octopi and cuttlefish are really, really smart.
Right. And also a good thing about that is that these larger ocean worlds, even though they have more gravity, because because life that is more stress on it, typically not going to grow as large as life on less gravitational energy. So, like Mars, if or Mercury or Pluto sized planet had life, it would probably be bigger than us, larger than us. It's more likely for that. But on planets where there's more gravity, organisms are going to be smaller, hence they're probably not going to be as intelligent or as well more likely. So having a world like an ocean world, it's I would say that's a good candidate for intelligent life. Um, now, in terms of intelligence overall in the universe, um, what do you think intelligence is? Like the quotient between intelligent life and microbial life is. Like, what do you think is more? How rare do you think intelligence is? Just to speculate. Just to
Yeah.
speculate.
So this is pure speculation because as a
Right.
scientist, I have to tell you, it's purely my gut.
Yeah.
I think finding microbial life is going to become common. I think we're
Mm,
going to find microbial life on a lot of moons where we never thought to look on moons because,
mm,
of course, it's got to be a planet. No, moons may be more common than planets. Second thing, I think because we're terrestrial, it's difficult for us to think about intelligence in oceans, even though we have octopi, whales, um, we dolphins. They're all smart animals, and they didn't evolve on land. So we have to stop thinking they have to be bipeds to be intelligent. Octopus use tools. Cuttlefish
mm,
communicate using light. Um, I think we have to
mm.
start figuring out that, the difference between an octopus and a human is not as much as we used to think.
Right.
So, do I think there's other intelligent life out there? Yeah, probably on ocean worlds. Can they leave their world? I don't know. Can they build a
Mm,
computer? I don't know.
that's a good point. That's a good point. Yeah,
But
would they be able to leave?
But could they build a society under the ocean or in an ocean? Yeah. I would consider a school of dolphins a society. They communicate, they take care of each other's youngs. They
Right.
do almost everything we do. They even use tools. So the difference is the next step. Could they get there? I don't know. But in
Right.
my fantasy world, yeah, I don't have a problem with smart underwater ocean cities of octopus moving around.
Right. I think I liked what you said. I think that as we learn more, as we discover more life out there, it'll force us to really broaden our understanding of what life means. Um, and I think we'll find life in places like you said where we never expected them to be, and that will change how we see life itself. So that's amazing. Last couple things. Oh, I want to talk about potential intelligent life that there might be a bottleneck for intelligence. Perhaps when you get reach a certain level, you're more likely to destroy yourself, you know? So, like Carl Sagan said very nicely, if perhaps we one day soar through the cosmos and we looked at planets, when we see the remnants of their civilizations in dust, right? That's a good possibility. Like we see on here on our planet, we are always on the brink of the end. Always on the brink of self destruction. What do you think?
Um, sure, we could wipe ourselves out. We do
Yeah.
have the technology to do it. I don't think we will because there's a will to survive. Life gives us a will to survive. So you might wipe out 90% of the humans. Humans are pretty crafty survivors. I think you would get a smarter new group of humans that may be well better than the previous group because they would have learned. Um, so I'm a positive person. I have a hard
Mm,
time looking at the negative. I always find a positive spin, so keep that in mind. Um, could there be filters? Yeah, the universe can wipe us out at any point in time. The universe is a very hostile place. But we've been here for 4.5 billion years and nothing's wiped us out. I suspect that there's millions, if not billions of worlds, millions of worlds in the Milky Way, trillions of worlds across the universe that are similar. Mathematically, as a mathematician, it's probable. Just in the observable universe, there's more stars than there are sand grains on the earth, to put it in
mm,
perspective. And
mm.
one of these societies probably never developed the thirst of war and is living peacefully and figured it out. And I would hope that that's more common than less common. There's
Right.
less war every year, even with everything going on right now. If you go back 200 years, there was far more conflict than now. It's easy to focus on the negative, but if you look at the positive, you go, yeah, we're a little better off now than 100 years ago.
Yeah, that's a very good point, actually. Like you said, when we look out in the universe, there might be most life forms that are intelligent, or going to be at least super intelligent, more intelligent than we are. But perhaps there's a survival of the wisest, much like there's survival of the fittest here, right? Perhaps the wisest survived, and the one and every alien that is intelligent is calm and they're peaceful. That's a good possibility. I want to talk about AI a little bit. Now you do. I now you talk about software development. What are your thoughts on AI? Can AI develop consciousness, and will that be the future of our species?
So, being someone who worked on early AI back in the 90s and
Mm,
2000s, it's really not artificial intelligence. It's a
mm,
beautiful buzzword. It is machine learning
mm,
and it's algorithmic programming, and you can do amazing things with it. But at no point in time is it real intelligence yet. But at some point in time, we may be able to synthesize intelligence. And I would think that's years into the future. It was predicted to happen by now, and we're closer. But until you know what the end time is, you can't hedge a guess. It's like people ask me, what percentage of the universe's knowledge do we have? Well, unless we knew all the knowledge, we don't know what percentage we're at. I think artificial intelligence, if we ever develop a sentient being that's a computer, we would be smart enough to program it in such a way that it would have morals and it would understand right from wrong, because generally we all do. And I think it would enhance our society. If we're ever going to travel the cosmos, this human body
mm.
sucks. We
Exactly.
live at most 100 years.
Yeah.
We need chemical fuel
Mm,
and we create all this waste. Well, we could take our sentient creations and have them explore the universe. So I've always told my classes, if we ever met the aliens, we wouldn't be meeting the aliens. I suspect we would be talking to their technology.
Right. Um, yeah, that's a good point. And most if there is intelligent life out there, it's most likely robotic, or most likely, like you said, um, this synthetic intelligence. Um, I was going to talk about perhaps if there's. I want to talk about Carl Sagan a little bit. I don't know if you. He's one of my heroes. I want to talk more about your purpose as well. But what do you think about Sagan? Have you ever heard about him? Do you know much about him? And what inspires you to keep going in science and keep doing what you're doing?
So, yeah, I'm an astronomer. I know Carl Sagan. I've watched every Contact. I've read his nonfiction work. I read one of his fiction works, and I I I have a different taste in science fiction than Carl Sagan. What I liked about Carl Sagan is he can take a complex problem and break it down in such a way that you can understand it.
Mm.
He can also inspire people, and that's what I try and do. I'm nowhere near Carl Sagan. Don't even get me started. Carl Sagan could inspire a generation of people to do better and to break down these complex things. And I think that's his gift, was he gave us a vision that was
Mm,
totally positive, and he explained complex things very simply. And that is a very difficult thing to do. Um, so my purpose, the purpose of my channel and my purpose of my life is to leave the world a better place than I found it.
mm,
I have 2 daughters. I want the world to be better for them than it was for me. When I grew up, you got beat up if you were a nerd. I was a nerd. I got beat up because I
yeah,
was a nerd. Now, nerd is a positive term because all of us nerds, instead of fighting back, we change society to make it better, that we accept people for who they are.
mm,
This is why I have this view that we're getting better. We have anti-bullying campaigns. In school, the teachers bullied the kid. I got beat up by a teacher because I was able to solve a problem faster than he could. Nowadays, police would have come in and done
oh
something.
my
I
god.
went to the principal and they said, "You should get stronger." It's a different world we live in that's
Yeah,
far
yeah,
better. There's problems. So my personal belief is I want to leave the world a little better place. And on my channel, I want people to be inspired by the universe to go be a doctor, go be a nurse, go be the best person that you can be and pay it forward. And if
mm,
you make your corner of the world a little better and I make my corner a little better and a million other people, imagine how much better of a world we would have every day. So that's my purpose.
great, great. Yeah, I loved what you said about Carl Sagan. I think that he showed us that science brings out the best in us, and that it's a very unifying thing and a very humbling thing to do science. It's a scientific perspective. The cosmic perspective is a very humbling thing. He also brought like this spiritual aspect. I'm not talking about like this crazy spirituality, but I'm an atheist. But when we talk about like this emotional aspect to science, like it makes you feel something when you look out in the night sky, right? It makes you feel something about being human and being alive. It's quite a remarkable perspective. Um, so yeah, I would say that my purpose is the same: is to leave the world a better place than I left it. And that's what I try to do with my channel. And I'm not a scientist. Well, I have a science background, but I try my best to inspire people to learn on their own. And I think that's what you're doing more, and that's why I appreciate you. And yeah, that's it. Did you have any other thing you want to talk about before we go?
I love your channel. I
Oh,
hang out in there
thank
every
you.
once in a while. I enjoy um, inspiring people, and you inspire them differently than I do. And I don't think there's one way to do it.
Right.
Um, I also try and tell people, yeah, they can get overwhelmed by the universe, and they can
Mm,
feel small and insignificant, but there's a difference. you understand the universe you live in, that makes you special. So the more you understand where you are, the more special you are. So don't feel insignificant because the universe is massive. Be significant because you understand the universe is massive.
Wow, yeah, that's great. And exactly, I think that the more I learn about the world, the more I appreciate it. The more I learn about my world, wherever the world we live in, wherever this reality is, the more I begin to appreciate it more. Um, and that's what science does the best. So, thank you for being here,
Thank you.
Professor. Thank you, and hope you have a great rest of your night. And bye, everybody. See you next time.
Thank you.